Hello, everyone. I'm Anshu Narang, part of NSO team. I'll be covering vBranch core function pack, essentially how we develop this use case to support Virtual CPE and VNF orchestration using NSO. Okay, so here is the high-level agenda. I'll go over the vBranch use case and what problem vBranch solves. Then we'll dig deeper into the service models and how we implemented the reactive fast map. I'll be covering portions of it, and then we'll get to the demo, wherein we'll bring up ASAV and ISRV, the virtual router and the virtual firewall. Followed by that, I'll go over how would you go about consuming whatever you saw. Okay. Okay, before I get started, I wanted to update you guys on as to what a core function pack is. So core function pack is essentially NSO BU supported application that is essentially conforming to key Cisco use cases. And here are three core function packs that we are developing. I'll be covering vBranch core function pack. And there are others as well, software-defined WAN and secure agile exchange. Okay. Moving to the use case. Imagine a branch office that is newly set up and desires internet connectivity. So here is the typical workflow or flow for how things happen. Okay, so branch office would kickstart a router order. A router would essentially ship. It will reach the branch office. And you aren't done yet. Now you'll need someone to come in with networking expertise who can bring this router online and kickstart next set of things, bring it online. And if there are other branches to be connected, there is yet additional configuration to be pushed and managed to keep it up and online. And that's when you get internet connectivity or WAN connectivity. Now, as need for services grow, imagine that they need a firewall now, or branch office site that we just set up needs a branch site. So same set of process would get repeated, which means it will take time to set it up, right? It will require extra cost, networking expertise to get it up and functional. And the same process is repeated if you have need for more VNFs. Like if you look at this case, it's WAN acceleration. So you'll require same set of flow, and which means additional cost and additional expertise or time to be needed. So how does vBranch core function pack solve this problem? It essentially solves these problems by leveraging ENFV, which is Enterprise Network Function Virtualization family of devices that essentially supports virtualization. And NSO has this vBranch core function pack, which is leveraging PNP for zero-touch onboarding of this ENFV device or virtual CPE. And it brings up our VNFs leveraging NSO, rather leveraging NFVO. Moving on, same use case. Now, if you were to add a firewall, all you need to do is single click, push in the configuration data onto NSO, and core function pack will bring up ASAV. It will stitch it, bring it up, which means less time, probably services up within minutes, and less time needed as well. Okay. Again, same use case. It can be easily applied to VWAS, which is WAN acceleration. So you can bring it up within minutes and have it up and functional. So aim for vBranch core function pack is to reduce cost and time to bring up the service on a branch office site. Moving on to service models and implementation. So before we get started, I'll go over what's catalog. So you can think of catalog as typical service globals that we have, or more of administrative settings that you configure once, and then you leverage it at the service instantiation time. Essentially, you instantiate N services, and all this data gets leveraged. So this is kind of Bootstrap data that's configured once. Let me start with NFVO. Again, when I talk about NFVO, this is HC Mano compliant package that NSO comes with. And here, the terms that I'll be using are essentially compliant to HC Mano. So VNF descriptor, that essentially defines the software image required to boot the VNF, the compute needs, the storage needs of the VNF. And that's what is covered under the descriptor. Then networks covering the basic management connectivity, as well as data networks that you desire to have on your VNF. Getting to the catalog element, it's essentially covering the service-specific data, meaning if you require a certain day zero, you can kind of define it under VNF deployment and leverage it for your use case. Again, this provides some kind of a customization that we'll look at as we go further. Branch CPE, this is nothing but a profile or a type. Again, it's trying to reduce the amount of information that's needed at the instantiation time, and you're bootstrapping kind of the administrative data. Okay. Now, getting to the left-hand side of the world, that's VNF. Again, what you get to define here is a branch CPE. Essentially, you'll have a leaf ref pointing back to the profile that we had created, and you provide serial, password, the basic details that are needed for the CPE. Any sets of virtual networks that you desire to create on the branch CPE for chaining VNFs, that's what this network covers. And VNFs with its desired compute needs, storage needs, and image is what is being captured here. And again, we'll be having a deeper look when I get to demo. Okay, and then CPE day one configs if you desire to push any. Okay. Before we get into the reactive part, I wanted to go over the layout of packages. So here is our NFVO package that comes from NSO. VNFD we already covered. If you look at NFVIS, this is essentially the infrastructure software that's running on ENFV family devices. All these devices have consistent software running. And that's what we're using to push configs down to the devices or receive notifications. And again, ENFV device is a netconf-based device. Getting to the PNP server, it essentially is implementation of Cisco plug-and-play protocol. And again, it does the PNP handshake, passes down the desired day zero, so that we can manage it with zero intervention or zero touch. If you look at vBranch package, this package is built on top of NFVO and PNP as a stack service. And the only difference here is that in our typical packages, you write templates that are pointing back to devices. In this case, your templates are pointing to these stacked services that exist here, PNP and NFVO. Okay? And I'll be going over create a little bit more. Catalog, I just covered these models. vBranch service models I covered as well. Plan is nothing but service operational data that has insight into where we are with respect to the creation request. And then notifications to keep Northbound up to date on where core FP is with respect to the request. Okay, and it avoids polling, which is efficient. And this block kind of covers all the create code, right? So NFVO template pointing to VNF info, kicker corresponding to the operational data that you see, and likewise for PNP, there is a stack service template that's attached here. Okay, now I'll get to the typical flow. You provide the service instance data, confirming to this service model or vBranch service model. Create code kickstarts. It applies the NFVO template, essentially creates VNF info service, and we'll be seeing that in the demo. And it also adds kicker on NFVO operational data. Okay, this is for the reactive behavior. as to when operational data changes, you can update this service or take subsequent steps of applying day one or doing other things that you desire. NFVO then takes this request, pushes the config down to the ENFV device. Once the config is pushed, ENFV device kickstarts the next step, that is bring up of this VNF on this device, right? And it sets up the basic monitoring so that it knows when VM is alive, it can notify through notifications. Once the monitoring check succeeds, it will kickstart or push a netcom notification, which NFVO would receive. And once it receives, it will onboard the VNF into the device tree. It will do sync from, and it will ensure that VNF is ready to take configs or day ones that we desire to push. And once this is done, VNF is ready, NFVO will update the operational data. And that's when the kicker that we had set up from the reactive fast map service will redeploy the branch service. And upon this redeploy, either it will push the desired day ones or other northbounds can act on it. In this case, it will update the plan, push notification northbound as to services up and functional now. Okay. Getting to demo. So here is what I intend to share today. Again, what is being shown here is an ENFV device, specifically ENCS picture. And here we'll be bringing up ISRV, ASA. We'll be chaining them with this virtual network that we'll be creating on fly. And along with that, we'll be registering the image and flavor required to boot ISRV and ASAV. Okay. So the only prerequisite here is this particular device has been shipped, and it's at the branch office site. It has the desired WAN and LAN connectivity. Okay, and these are pre-existing networks that are up and functional. All you need to do is plug in the desired cables. Okay. We can also assume that vBranch core function pack is installed, and it has all the desired packages, PNP, NFVO, and vBranch package itself. And here is the Bootstrap data, which is covering the VNFD for ISRV. And I'll be showing on CLI as to what other or additional VNFDs that exist in the system. Again, very simple. It's pretty much covering the compute needs, the storage needs, and it's covering the image that we desire to leverage to boot the VNF. Okay, let's get to the CLI. So here we can see there are 4 VNFDs bootstrapped. We'll be leveraging ASA. Oops. Hold on. I think it's not on my display. Sorry about that. Okay. So here are the VNFDs that are bootstrapped. You see there are 4 VNFDs. We'll be leveraging ASA and ISRV. Moving on. The next set of configuration data that's bootstrapped is kind of catalog, and it covers the ENCS profile, which is representing a type, the pre-existing networks, the day 0 that we desire to push via PNP. And it also covers the onboarding for the CPE. Okay, and like how we saw configuration data for ENCS, likewise you can have or define different deployments for VNFs that we intend to bring up, covering some of the monitoring information, some of the port forwarding information to conserve WAN IP addresses, as well as day zero URLs and Bootstrap data that you wish to consume. Okay, let's move on to instantiation. Okay, let me share the catalog first. So here is the catalog that's Bootstrap. Here are different branch CPE profiles that we have in the system. Okay. Yeah, for some reason it's okay. So here are the different CPE profiles that we have bootstrapped. And here are different deployments. We'll be leveraging ASA as well as ISR for instantiation. And likewise, we'll be leveraging ENCS profile. Okay. Here is the typical instance payload. And core function pack allows you to instantiate the entire intent in one go, or you can go step by step. I'll be going step by step so that I can go over different steps and kind of describe what's happening behind the scenes. Okay, let's get to the first step. Oops. Sorry about that. Okay, so let's look at all the services in the system. So there are no services right now that exist in the system. Let's look at PNP unclaimed. So right now, given I described the branch CPE is up and functional and it's residing at the branch side, it had reached NSO. And NSO doesn't see any service corresponding to this serial, and hence it has added it to the unclaimed list. PNP list. Let's look at the devices that exist in the system. So there are no devices in the system. Let's kickstart creation of the CPE now, or rather the vBranch service with CPE. So here is what I intend to instantiate. I've given it this service a name, a type. This is the same profile that I shared. So the service would be inheriting all the information from this particular profile. The password that I decide to or desire to use to connect to the CPE, and the desired serial number, again, the same serial number that's added to the unclaimed list. Let's commit this information. And in vBranch function pack, what we have added additionally is the plan support. So essentially, it allows you or provides you insight into where core FPA is with respect to creation. So let me go over the specifics. So here, if you look at CPE, this is nothing but a component. In it, essentially, it describes that the config has been written, that is, PNP map has been created, and it covers the time when PNP has called home and the time when PNP handshake happened, when device got onboarded into the NSO device tree. We were able to sync from, add it, update all the operational data. So it's kind of reflected as in the service operational data. And again, it provides a deeper level of information as to when different things happen in time. Okay. So here is what we did. We essentially onboarded this CPE. This is the information we provided and committed the service. This CPE is now onboarded into NSO. So let's look at the, OK, I'll share the device tree, and then I can kickstart. Oops. Not saving it for some reason. OK. So here is the NCS device that got added to the device tree. And that's what is reflected in the operational data as well. OK. Moving on, let's create the virtual network. Again, this network we'll be using to chain ASA and ISRV. OK, so I'm just committing a virtual network. Committed. Again, I'll be flipping the screen and going back to what exactly happened after we get to the next step. So what we have done is we have created the virtual network that we leverage to bring up or chain ISRV and ASA. Let me now register the image and the storage and other asks for the VNF. So here I'm registering both ASA and ISRV image flavor, which covers storage and compute tasks. Okay. And as I mentioned, plan will provide insight into where core FP is with respect to the creation. In this case, we can see that image has been, the config to register the image has been pushed to the device. Core function pack is waiting for notifications to come back from the device. And now we can see the image flavors have been registered on the device. Now let's see what exactly was done. So here we were able to create this virtual network on the device, as you see in this picture. And we were able to register the image and flavors on the device as well. OK? Let's move on to the next step. Now, what we intend to do is bring up ISRV and have it connected to the WAN interface, or have one of its network interfaces connected to WAN, and also desire to have it chained with ASA. So we'll be attaching it to ServiceNet. And then we'll bring up ASAV, and we'll attach it to the LANnet and chain it with the ISRV. Yeah. OK. So let's So here is what I'm about to commit. So here is the same CPE that we created the service for. I'll be bringing up this VNF with this name. We leverage the ISR deployment, the VDU that we just registered. Again, one of its network interfaces would be attached to ServiceNet, the virtual network that we created. The other one would be attached to WANnet. OK. Now let's look at state of things in plan. So here is the current state of things for ISRV. It has been registered, meaning it has been, the config or request has been written to the device, and that's what plan is reflecting. Again, it covers the time when it actually got deployed on the device. And it also covers when it came to life, or when VM alive or monitoring checks succeeded. OK. let's load ASA. So here, I'm leveraging the same deployment that was bootstrapped, the desired image flavor, and I'll be connecting the firewall to LANnet, and we'll be chaining it with the ISRV, as we saw in the picture. Okay, let's commit this information, and let's monitor the state of things. So in this case, it got committed. Now, core function pack or plan is indicating that VNF is booting. So plan is kind of very useful here, given it's providing deep insight into where the VNF is with respect to instantiation. And as things move, plan will get updated, like how you see in this picture. Okay? Now, let's look at the devices in the device tree, just to see if VNFs got added or not. So here, you can see the ISRV added to the device tree. Sorry, I executed. Okay, so here is the device with the desired config or desired day zero config that's added to the device tree. And likewise, you also see ASA. ASA, ISRV, and ENC. Okay. Now let's look at some of the notification support that we have. So again, this is to ensure that northbound doesn't need to poll. This information is kind of pushed via netconf notifications north of NSO. So let's look at, I'll be sharing here one notification, and then I can show a list of things that Core FP has pushed. So here we can see service notification. Likewise, notifications exist for each of the entities that we saw being instantiated, and it's covering in detail view of what devices got onboarded for each of the entity and other details, and some of the debugging details as well. So you can dig deeper on the device and check further. Okay. And here is again list of things that we had pushed. So it's covering VNF, service, and again even other entities. By default, it shows last gen. So here it's even covering VDU and whatnot. Okay. This essentially concludes what I wanted to cover on the demo side. Now let me quickly get to consumption. So there are two consumption models. Essentially, this is direct consumption model, wherein northbound system is sitting on top of Core FP and is consuming the APIs that we just saw. Frederick has a lab on Thursday. He'll be covering in detail wherein northbound system would be Ansible in this case. So he'll be covering that use case. Moving further, this is the preferred consumption model. And this is similar to how vBranch core function pack was built on top of PNP and NFVO. You can define your own service models. You can define the vBranch template, like how vBranch was developed. Define VNF day ones that you desire to push. Kicker corresponding to the plan that we just saw. And this particular service operational data. And again, the entire power of NSO is available at this level. You can define whatever you desire. In fact, if you want, you can define n branches that can be grouped together, instantiated with common policies and whatnot. So total flexibility is available for extension or customization. Well, with that, that concludes my demo. So I'll wait for any questions.
Any questions? How many can raise their hands? No. All right.
I think.
Well, then I guess that means lunch then. Thank you.
Thank you.